increases the effect of the electrons hitting it, causing the anode and cathode to have two different voltages, both of which are greater than that of the original signal. This makes the signal larger and more powerful, meaning it amplifies the sound. With those three key components now assembled into one unit, the inside structure of the tube is complete. Now for the bulb, which will encase that unit. A glass blower skillfully crafts it out of hard, laboratory-grade glass. Using a high-temperature torch and glass-making tools, he melts the open end and seals it off. Then he blows in a bit of air to shape the end into an evenly rounded dome. Now he mounts the bulb on a lathe to complete the shaping. Keeping the glass evenly heated, he blows in just enough air pressure to keep the bulb from collapsing inward. When the glass reaches just the right temperature, a die presses against it, setting the final shape. Next, they mount a glass collar over copper wires clamped into a motorized vise, then insert a glass straw called an evacuation port. As the vise rotates, they heat the collar uniformly with stationary torches. Using a handheld torch, they remove any stretches or runs in the softening glass. When the time is right, they activate a die to press the glass into the final shape. This completes the stem on which the tube's inside structure sits. The wires protruding from the top of the stem connect to the structure's terminals. Now they put this assembled unit on a turntable and center the bulb over it. As the turntable revolves, they heat the bottom of the bulb. As the glass melts, they press it inward, fusing it to the stem. They remove the excess glass and continue heating to ensure the bottom is fully sealed. Next, they prepare to suction out the unit. This step is critical to the tube's performance because air molecules hinder the flow of electrons. Technicians fuse the tube's evacuation port to the glass evacuation line of a vacuum pump. The pump then extracts the air through the port. At the same time, they heat the tube in a pull-down oven. This increases pressure inside the tube, creating a stronger vacuum. Next, they run an inductive heater over the tube. This dislodges damaging impurities, enabling the vacuum pump to draw them out. They target the stem area with a second inductive heater to draw particles called ions onto the glass permanently so that they can't later damage the tube. Finally, they connect the protruding wires to a plastic plug-in base. There are subtle technical differences between tubes of the same model, so the factory tests each tube, then matches